Hey folks, probability distribution. We're now back in our IM3 textbook. We veered out for about a week. Went to our IM2 textbook in module 22 that we skipped last year, so to talk about permutations and combinations. So here we're going to talk about what is the probability distribution for a discrete random variable. We'll talk about that, and how can it be displayed. Okay, so we're going to mostly display it with a histogram, okay? So probability distribution is a display that gives the probability of variables of the random variables, of values of the random variables, and it's often we're going to be representing this in a histogram. Okay, so here's an example of a probability distribution of rolling numbers on a cube. So the probability of rolling a 1 on a cube is 1 out of 6, so 1/6. The probability of rolling a 2 on the cube is 1/6. Same with a 3, a 4, a 5. So these all are 1/6 right there. So this is, if you can think about wrapping a rectangle around your graph right there, it is called a uniform distribution. They're not all uniforms. I'll show you a symmetrical one, and then on your assignment today you're going to see a skewed one, and I'll let you decide which way it's skewed. Okay, so anyway, so binomial situation involves two choices, like on and off, or heads or tails, or male or female, or left or right, or success or failure. There's on and on. You can keep doing it when there's just two choices. Okay, so the binomial probability of R successes in N trials is given by, here it is a combination formula. So the probability of R successes in N trials, so if you flip a coin for 5 times, N would be 5, okay, is NCR. And then P is the probability of success. Q is the probability of failure. Well, if the probability of success is a decimal, then this is going to be 1 minus that. Or if it's a fraction, this is going to be 1 minus that. And we're going to do fractions, okay? And then to the R power, whatever that is, and this is going to be N minus R power, okay? Where P is the probability of success, and which is a decimal or a fraction that's less than 1, and Q is 1 minus that, okay? So let's find the probability of each, of getting 0, 1, 2, 3, 4, or 5 tails if we flip it 5 times. Okay, so here's our formula. So n equals 5 because of this 5 right here. We're going to flip it 5 times, all right? So when I plug in this number, that's going to be r. So we'll plug in 0 here, and then right here. 5 minus 0 is 5. Okay, and so what is the probability of getting a tails if you flip a coin? Well, there's one tail, two sides, so the probability of getting one tail is 1/2. So that's our P, that's our success. So Q is 1 minus that, so it's also a half. All right, so here's 0 tails. Plug in R equals 0. N equals 5. Here's N right here. Okay, so 5C0 is going to be 5 factorial over 0 factorial times 5 factorial. That's just 1. Anything to the 0 power equals 1, so we have 1 times 1, and then 1 to the 5th is 1, 2 to the 5th is 32, so we get 1 over 32. So that's our probability. If you flip it 5 times, then 1 out of 32 chances is going to be your likelihood that you get 0 tails. Okay, 1 tail, plug in 1, so R equals 1. Here it is again, and this is 5 minus 1, okay? 5C1 is 5 factorial over 1 factorial times 4 factorial, which is just 5, okay? This is times a half. This is going to be a 16th. 1/2 to the 4th is 1/16, okay? And then 5 over 1 times 1 over 2 times 1 over 16 is 5 over 32. Okay, let's do that for 2 tails. And when we crank that out, we get 10 over 32. Okay, 3 tails, again, we get 10 over 32. 4 tails, we get 5 over 32. And 5 tails is 1 over 32. Okay, it's just plugging them in. And I spent about 10 minutes yesterday doing that with my students. So now let's create a histogram using this data. Okay, so here's our probability. So typically this is our x-axis, this is our y-axis. So this goes down here. So this is our x-axis, so the number of tails, 0, 1, 2, 3, 4, 5. And then this is my y-axis, so the probability is going to go up here, and it's going to go from 1 over 32 all the way up to 10 over 32. So something like that. Okay. All right, so now let's do a histogram is where the bars are close to each other. So let's make a bar at 0 tails right here. So we'll go halfway over here, and go up to 1 over 32. So we'll go halfway over there. So there's 1 over 32. Okay, the next one is 5 over 32. So there's 5. Go up 5. The next one is 10 over 32. 10 over 32, 5 over 32, 1 over 32. What would you say? Would you say that was symmetrical? I would. Isn't it the same on both sides? So it's a normal distribution, okay? All right, okay, so let's find the probability of getting at least 3 tails. Well, we did the hard work over here. Here's 3 tails is going to be either 3 tails or 4 tails or 5 tails, at least 3. So here's the probabilities. We just add those up. Okay, so we're going to get 16 over 32, which is a half. Okay, find the probability of getting at least 1 heads. Okay, well, the long way is to add all these up because there's 1 through 5, or the shortcut way is it's the opposite of getting no heads or 0 heads or 0 tails. Did I say heads? Tails, okay? Heads would be the same. We get the same thing. So it's going to be 31 over 32 because this is 1 over 32. This is the only way we can get 0 tails right here. So the probability of getting at least 1 tail is going to be the opposite or the complement of getting 0 tails. So 1 minus that would give us 31 over 32. Okay, I don't know what the book would suggest if they want you to give you the fraction answer or the decimal answer or both. Doesn't matter, they're both pretty easy. Okay, all right, so here we go. Another binomial experiment consists of flipping a coin for 5 trials. We're getting the tails is considered a success. Okay, this coin lands on tails 75% of the time. Okay, right there, you guys, that coin is a biased coin. If it's going to land on tails 75% of the time, then we have a biased coin. So P is 75%, which is 3/4. So find the probability of getting the tails at least 4 times. Okay, there's our formula. This is going to be 3/4. This is going to be 1 minus 3/4, or 1/4. And then it's the same thing. We're just doing the same thing, except the probability changes. So at least 4 means you're getting 4 tails or 5 tails, which means we're going to add. So there's the probability of getting 4. We get that right there. Probability of getting 5, and if we do it right, we get that. So the probability of 4 or 5 is the sum of those. And so if we add them together, let's see, I think 8 goes into both of those. Yeah, 4 goes into both of those, which you'll find out 4 goes into, 2 goes into that. So 4 and 2 both go into that, or 8. 8 goes into that 61 times. 8 goes into that 1. Let's see, 160, my brain's shutting down. 128, gosh, I was thinking 16 in my head and saw 16. 6 anyways. Anyway, so there it is right there. Okay, all right, so what about using the same biased coin above? Find the probability of getting at least 1 tail. Okay, now at least 1 is, again, the opposite of getting 0 tails or no tails. So we can find the probability of getting no tails right there. Plug it in, so r equals 0, and then whatever this is, we're going to take it away from 1. That's going to be our answer right there. So we get 1 over 24. So the probability with this guy, this situation, and this biased coin of 75% of the time, the probability of getting at least 1 tail is going to be 1023 over 1024, about 99.9% of the time. All right, if you are in my class, you're going to have that as a homework assignment. And here's the answers, you guys. You're doing numbers 1 through 4. Let me see if I can at least enlarge these guys. So, well, can you see those? Here's numbers 1A and B, so I'll just enlarge that if you guys don't mind. There's 1A. Pause it, you guys. I got to go back. Okay. Here's that's 1A and B. Here's 1C and D. Okay, so that would be right here. Sorry about that, you guys. It's just there's a lot to it. So there's 1C and D, and you would pause that. Let me go back and get 3. Okay, so this one's going to be a little harder to see. Maybe I can you can pause it as we're doing this. So here it is right here. Here's 3. Okay, there it is right there. All right, can you see all of that? If you can't, let me do this. There's 3A and B and C and D, and I'll slide it up for you guys, okay? Hopefully you're pausing it. And then there's the rest of them right there. All right, you guys, take care.